Well, good afternoon, statistics students. I hope everyone's doing well today. Sorry I can't be with you today, but I'm with you in spirit. All right, is everyone ready? Let's grab something to write with, something to write on. You'll definitely need a graphing calculator for what we do today, so hopefully you've got one already. Well, all right, let's get going. Sammy, how are you today? Yeah, I know that's just weird. But hopefully your day's going well. Max, hopefully it's going well back there. Alex, hopefully you're doing well. Everyone else, good to be with you. Hey, today we're taking notes on something called estimation and confidence intervals. So jot down these two ideas to start. A point estimate is a sample mean, which we call x bar, or a sample proportion, which we call, this is kind of weird, we haven't seen this before. This is called p hat. So when you see a p with a little mark above it, it's called p hat. Okay? So here's how we would use this. Let's say I was asking you this question. I asked you to guess, what do you think is the average age of all the teachers at Oregon High School? I don't know what it is, but if we could guess, you might say something like, I don't know, about 35 years old or so, maybe 40, somewhere around there. Now, if you were just to give one number like that, chances are that one number would not be correct, okay? That is what's called a point estimate. You're just giving one number. What would be a lot better would be to give a range of values, which would be what's called a confidence interval. So let's scroll down a little farther and write this down. An interval estimate is some range of values. So for example, for that example I gave, you might say the average age of the teachers here at Oregon High School is between 35 and 40. Okay. Or we can write it something like this. Like you could say it's about, I'm going to pick some little different numbers here. You could say it's about 37 plus or minus 3 years. So in that case, it would be from about 34 to 40. Okay. So this next unit, we're going to be studying how to calculate these confidence intervals, because what we don't want to do is what I just talked about doing. What we don't want to do is just make a guess. So if we really wanted to know what is the average age of the teachers here at Oregon High School, here's what we would do instead. We would take a sample of teachers. We'd survey some of them. We don't have to survey all of them. We'd survey some of them, and we get an average. Let's say we survey some and we get an average of about 34. So based on that number, we would know that our range should be somewhere around 34. So maybe our range would be something like 34 plus or minus, I don't know, 5 years. In which case the average age would be somewhere between 29, which is less than the true average, which is less than about 39. Okay, so we're going to talk about how to get these ranges and how big they should be. We shouldn't make a range that's, let's say, from 0 to 100. And also, if we said from 33 to 35, it's probably not accurate. So we're going to talk about how to come up with those ranges. So what we're coming up with is what's called a confidence interval. It's an interval obtained from a sample with a specific confidence level. So it's an interval, it's a range of values that we get from a sample. So we start by surveying some teachers, or depending on what we're getting, some students, some people in the community. Start with a sample of some data, and then we need a specific confidence level. So do we want to be 95% sure? Do we want to be 99% sure? We can never be 100% sure, but our confidence level is how sure we are. So we might say we are 95% sure that the true age of teachers is somewhere within this range. That means maybe we made a mistake, but we're 95% sure that the true range is within here. 5% of the time, we're probably not correct. Okay, so let's talk about how to calculate these confidence intervals. All right, I'll give you a minute to jot this down. So this is for the confidence interval for a mean or an average, like the example I used on the previous page. Okay, so to calculate one of these confidence intervals, we're talking about an interval for an average. First decision, this is something new to us. We have to decide whether we should use what's called a t-interval or a z-interval. Now, we have worked with z-scores in the past, and z-scores are related to these z-intervals, okay? And we know z-scores come from these normal curves. So if we sketch a normal curve, we can use that to come up with z-scores. Now, about 100 years ago, there was a guy working at the Guinness Brewing Company, and he noticed that when you selected a small number of samples, it didn't quite follow a normal curve. It was more like a flattened normal curve. Let me see if I can get it right. So it's still that same shape, but not quite as high and wider than it should be. So when we have a small amount of data, we use just a little bit different calculation. We use what's called a t-interval instead of a z-interval, okay? So turns out if you have less than 30 people or less than 30 samples, or if you don't know your standard deviation. So basically, if you have any doubts about your data, we use a t-interval. It's just a safer calculation. If we have a large sample, if we survey a lot of people, and if we know the standard deviation, so if our data is pretty safe, we use a z-interval. Okay, that's step one, to make that decision. Step two, I'll give you 30 seconds to jot this down, and we'll talk about this part. So the second thing we want to decide is, what is our confidence level? And if you take a statistics course next year or at some point down the road, you'll notice that whenever you calculate these confidence intervals, they use either 90, 95, or 99% significance. That just tells us which z value to use in our formula. And I'll tell you what, in this class, almost everything we're going to do is going to be 95% significant, okay? So the z value we're going to use for almost all of our calculations is 1.96. Okay, let me scroll a little bit here to get to our third step. Third, we're going to either use a formula or our calculator. Now, I'll be honest with you. We can do all of these calculations on our calculators. That is a huge plus. We have to understand what they mean, we have to interpret them, but we don't have to do all the calculations. I'll give you this formula regardless. Let's talk about what these parts of this formula are. X bar, that's your sample average. So if you're surveying, let's say, 20 teachers at the high school, their average age would go right here. Plus or minus. 1.96 comes from this value up here. If we choose a different confidence level, we plug in a different value. All right, in parentheses, there's our standard deviation over the square root of n. Now, you might recognize this. It comes from that central limit theorem that we learned earlier this year. Now, that's our formula for a z-interval. For a t-interval, it's going to be the same formula, but we're going to actually have a different value in this spot right here. So instead of using a z-score, we're going to use a t-score. But I'll be honest with you. I'm not going to use this formula for most of the calculations I do over the next couple weeks. Instead, I'm going to use my calculator. So on our calculator, here's where these commands are. You're going to press your stat key. We've been in there before. We're going to go over to the test menu. Hey, we haven't been there before. This is new. And the tests we want are either choice number 7, which is a z-interval, or choice number 8, which is a t-interval. Okay, so here's what I want to do next. I'm going to put up here a couple different homework problems. We're going to do these together, and they're going to be examples of these z-intervals and t-intervals, okay? All right, so let me put the first one up here. Now, do not write all of this down. This is in your textbook. It's problem number 4 of your next assignment. Let's just read it together. Let's interpret what's being asked here, and let's come up with an answer. So it says a study of 35 adult females. So right off the bat, 35 people, that's our N. The number of people that we're studying is 35. Okay, that's a big hint for something we need. So 35 adult females showed the mean, okay, so it's talking about an average, the mean systolic blood pressure to be 116 millimeters. So the average, the mean, is 116, and the standard deviation is 8.4. Then it says find the 95% confidence interval of the true mean of the population. Okay, so we're good to go. So we can either use that formula I gave you or our calculators. Now, going back to those decisions we made in our notes, first thing we have to decide, are we using a z interval or a t interval? What do you think? Okay, because the number of people is above 30, we're going to use a z interval. Okay, so let's get our calculators out. Now, I don't have mine handy, so I'm counting on you guys. So get out your calculator. Once you get that calculator out, I need you to press the stat key right in the middle of your calculator. And we've edited stats, we've calculated things, we've never gone to that far right menu, which is tests. We're going there today. We want to go down to either choice 7 or choice 8. For this particular problem, we already decided it's a z interval, so that's going to be choice 7. So go to choice 7 and press enter. Now at the top, there's two choices, data or stats. If we actually had all the data, like if our data was in a list, we'd highlight the word data. But in this case, we have the statistics. We know the average and standard deviation. So we're going to highlight the word stats. The next thing up there is standard deviation. So for standard deviation, you want to put in 8.4. X bar is our next choice up there. That's our average. Our average of our sample was 116. Next, it's asking for N. N is the number of people. Number of people is 35. Sea level, we're going to keep that at 0.95, and almost everything we do in this class is going to be 0.95. Once you have all that in there, you can go down to calculate. I'm going to get that in my calculator as well. Make sure I'm doing the right thing here. When you calculate, the answer is given at the top. It looks like this. And this is all you need to write down. 113.22, comma, 118.78. Here's what this means. We surveyed 35 people. Based on these 35 people, we are 95% sure that the true average blood pressure is between 113 and 118. Okay? Now, this does not mean, here's how not to interpret this. This is the biggest mistake I see students make. This doesn't mean 95% of all people have a blood pressure between 113 and 118. It does not mean 95% of all people are in this range. It means we are 95% sure the true average of everyone is between these two numbers. Okay? All right. Let's run through another example. And again, don't write all this down. It's in your book. It's problem number 5. Let's read it together. An irate patient complained that the cost of a doctor's visit was too high. She randomly surveyed 20 other patients. Right there, let's underline 20. So 20, that's the number of patients. That's a big hint that tells us which interval to use. And found that the mean amount of money they spent was $44.80. So there's our mean, there's our average, okay? The standard deviation was $3.53. Okay, so the first thing we have to decide, is Z interval or T interval? Since we only surveyed 20 people, we're going to use the T interval. Okay, so grab your calculator again. Press your stat key, go over to tests. This is going to be choice number 8 now. And when you go to T interval, again, data or stats, we want to highlight the word stats. The first choice here is X bar. X bar is the average of your sample, meaning from the people we surveyed, we got an average of 4480. The next choice is S sub X, standard deviation of the sample, which is $3.53. The next option is N, which is the number of people surveyed, that was 20. So why don't you enter everything you can in there. I will do the same. So 4480 for our X bar, 353 for our standard deviation, 20 people. We're again 95% confident. And here's the answer we need. 43 points, I'm going to round to 0.15, and 46.45. Here's what this means. It means if we surveyed everyone who went to that doctor, we are 95% sure the average cost that people would pay is between $43 and $46. Now, some people will pay $100. Some people will pay $0. We're not saying 95% of all people pay what's in this range. We're saying we're 95% sure that the true average is in this range. Okay? There will be people down here paying $0 or $10. There will be people up here paying $100 or even $200. The average is probably going to be in this range. Okay, so there's confidence intervals of a mean. Now we also have confidence intervals of a proportion or a percentage. Now, these actually are used a ton at this time of year with the election season upon us. So tomorrow actually is a voting day. I hope those of you who are 18 will get out and vote. I was looking at some political polls and it was saying the percentage of, I'm actually going to make something up here, percentage of Republicans who are going to vote for Senator Ted Cruz is about 40%. And then whenever you read these at the bottom, it says plus or minus 3% or something like that. So that's like saying they didn't survey everyone in Wisconsin. There's no way they can. But from the people they surveyed, 40% of them were going to vote for Ted Cruz. They are 95% sure that the true percentage is going to be between 37% and 43%. So anytime you see a plus minus, they're calculating one of these confidence intervals. So let's talk about how to calculate one of these. So our first choice now is to determine the confidence level. Do we want to be 90% sure, 95% sure, 99% sure? That's our first decision. Notice we did not have to determine are we going to use a Z or a T interval. For proportions or percentages, there's no such thing. Okay, so first, confidence level. Second, we're going to use either a formula or our calculator. Okay. Why don't you jot this formula down? Again, we're going to let our calculator do most of the work for us. We should have this anyways. We should have this as well. So what we're calculating is what's called a 1 proportion Z interval. And let me walk through this formula. We've got P hat. That's our sample proportion. So if we survey 100 people and we get 40% to say yes to some survey question, P hat is 0.4. Plus or minus, there's that number 1.96 again. And then we have the square root of, I know it's kind of hard to see, but that's P hat times Q hat. What on earth is that all about? Well, if P hat is 0.4, if 40% of people say they will be voting for a candidate, Q hat is 0.6. That's the percent of people who say they will not be voting for that candidate. Divided by N, which is the number of people. Now, P hat and Q hat always add up to 1. So 40% say yes, 60% say no. Okay. Okay. Now, to be honest, just like those earlier confidence intervals, our calculator does this work for us. If you press your stat key, go over to tests, it's choice A in that menu. So why don't you jot that down? Then we're going to take a look at an example. Again, this example is from your homework. Again, we're not going to write down all the words. We're just going to do the calculation together. Okay, you ready to go? Here we go. All right, don't write all this down. Let's read it together. A random survey of homes in Madison shows that 153 out of 240 had working smoke detectors installed. Okay, here's our main thing we need. we surveyed 240 homes. 153 of them said yes, they have a working smoke detector installed. We want to know a 95% confidence interval of the proportion of homes that have working smoke detectors installed. Now stop right there. This second part we're going to answer once we have our confidence interval. Okay, since we're talking about a proportion, something out of something, this is not an average anymore, it's a proportion. So on your calculator, press your stat key, go over to tests, do not choose choice 7, do not choose choice 8. The choice we want is choice A. It's what's called a one proportion C interval. And there is no such thing as a one proportion T interval. So basically, if you're talking proportions, this is what you'll use every time. All right, once you choose that, this is nice. You only have to put in 2 pieces of information. X is the number of people who said yes to your survey question. N is the number of people you surveyed. We are going to choose 95% confidence. Why don't you enter those 2 pieces of information? I will do the same. And when you're done, you can calculate. And here's what you should get. You should get 0.57, we'll go 3 decimal places, 0.577, comma, 0.698. Here's what this is saying. Based on the data we have, we are 95% sure that if we surveyed all the homes in Madison, if we went to every single home in Madison, between 57 and 69% of them would have a working smoke detector. So based on the information we have, we can come up with a range of values. We're 95% sure the true percentage of all homes in Madison is somewhere between these 2 percentages. Now, the mayor of Madison says 70% of all homes have a working smoke detector. Should we believe that guy? Mayor Paul Soglin, should we believe him? Well, it's not in our range. So I'm 95% sure that the mayor's wrong. I'm 95% sure the true percentage is somewhere between 57 and 69%. Now, with that being said, the percent he gave is not too far outside of our range. Remember, this is a 95% confidence interval. 5% of the time we'll be wrong, so maybe the mayor is correct. But still, I'm 95% confident that we are correct. So he could be right, but I'm betting my money on what we have calculated. Okay, there's one more calculation we need to do, and unfortunately our calculator does not do this one for us. So we need to make sure we get this formula down here. All right, here's what this last one is all about. In those political polls, you often see at the bottom, this poll has a margin of error of 3%. Well, how do we know that? Well, the more people you survey, the smaller the range will be. So if you just survey 10 people, you're going to have a pretty wide confidence interval. If we survey 10,000 people, you're going to have a pretty narrow confidence interval because you're pretty sure that the true average or true percentage really is within that range. So the more people you survey, the narrower the range. So let's say you want your range to be plus or minus 3%. How many people should you survey? Well, if we're talking about an average, again, not 3%, but let's say you want to be, let's say for that average age of teachers here at Oregon High School, you want your answer to be within 5 years of the true average. This is the formula we would use. Now n, that's what we're solving for, is the number of people, equals, there's that number 1.96 again, times the standard deviation divided by E. Now E is new to us. E is the maximum potential error. It's what you want to be within. So when you see the word within, that's E. So we want to be within 5 years, within $10, within, I don't know, whatever you want to be within, that's your E. Now, here's a key on this. If you get an answer like 99.2, we should always round up. Here's why. Well, we can't survey 99.2 people. If we round it down to 99, that's not quite enough. So we have to round up to 100. So always round your answers up, no matter what they are. Round up to the next closest integer. All right, last formula for us. If we want to find how many people we should survey for a proportion or percentage, this is like those political polls. You want to be within 3%. Here's your formula. So the number of people you survey, that's n, that's what we're solving for, equals p hat times q hat. So based on an earlier calculation, use p hat and q hat. There's 1.96 again. E is your error, what you want to be within. So for those political polls, if you see at the bottom it says plus or minus 3%. That means 0.03 is plugged into this formula. So if you want to be within 3%, what you use is 0.03. Okay, let's look at one example of this together. And again, your calculator cannot do this for you, so you're going to have to do some calculations here. Last example together, then we're done with our notes. All right, number 7 in your homework says, how large a sample is needed? It's meaning how many people do you have to survey to be 95% sure that the estimate of the mean, right there, so we're talking average, the mean income of entry-level accountants is within, so within, that's always our E, $150 of the true mean. The standard deviation of income is $950. Okay, since we're talking mean, we need that first formula on the previous page. So the number of people we should survey is equal to, in parentheses, 1.96 times the standard deviation over E, and we're going to square that. The biggest mistake I see people make, they forget to square. Okay, so the number of people we survey should be 1.96 times the standard deviation is given to us, $950, divided by our E, what we want to be within. We want to be within $150. And once we figure that out, we're going to square what we get. So please do that calculation. I'm going to do it as well. So 1.96 times 950 divided by 150. If you do that first part, you should get about 12.4. Once you square it, here's what the calculator gives you, 154.09. Now remember, n is the number of people. It doesn't make sense for us. Now, we can talk about an average being a decimal. The average number of people that live in a household in Oregon is 3.5. That's okay. But when we talk about the number of people we should survey, we should not have a decimal. We need to round up, so please don't leave your answer like this. Let's say 155 people. If we surveyed 154, that would not quite be enough. So we'll survey 155. Whoops. Okay. All right, hopefully this made sense to you. Now take a look at that clock right there. You've got about 10 minutes or so remaining. All right. You've got an assignment to take care of. This one's due next week, Wednesday. So since our assignment's due Wednesday, whoops, actually, I think I'm going to change things. Next week is Fine Arts Week. So I think this assignment, let's make this due on Tuesday of next week. That's going to be April 12th. Meaning our next test is going to be on Thursday of next week. Because I was looking at the Fine Arts Week schedule, and I think we're going to go to one of those assemblies on Friday, okay? All right, you guys, so 10 minutes remaining. Please grab a book. Some of these problems are done for you because we did them in our notes. Grab a book, see what you can do, get off to a good start on this. I'll be back tomorrow. I'll answer any questions you have. And we're going to do some different simulations over the next couple weeks to help us more fully understand confidence intervals. All right, you guys, have a great rest of your day. I will see you here tomorrow.